just like there are some functions whose derivatives you should just know, there is a similar set of functions whose antiderivatives you should just know. The antiderivative of x to the n with respect to x is x to the n plus 1 over n plus 1 plus c. Notice that I'm including an arbitrary constant of integration. This is really important for us when we are solving differential equations. The antiderivative of e to the x with respect to x is just e to the x plus c. Antiderivative of 1 over x dx. Notice that this is actually a counterexample to the first rule I went. This is only for n not equal to negative 1. If n is equal to negative 1, then you get 1 over x dx, and that is natural log of the absolute value of x when you integrate it, plus c. Notice the absolute value. In differential equations, we are often able to get away with leaving that out, but it technically should be there. The antiderivative of sine is negative cosine. The antiderivative of cosine is sine. The antiderivative of secant squared is tangent. The antiderivative of tangent is the natural log of the absolute value of secant x plus c. You can prove this for yourself by writing tangent as sine of x over cosine of x and then doing a u substitution. And lastly, the antiderivative of secant of x is the natural log of the absolute value of secant x plus tangent x. This is a weird one, but you can prove it to yourself by first multiplying the secant by secant x plus tangent x over secant x plus tangent x, which you can do since you're really just multiplying by 1, and then doing a u substitution.